Yo, what's going on, man? So I split up the Unit 12 test review into two parts. This is going to be the start of the second part. Of course, you see it says part two. This will cover the entire back of your test review, okay? So let's go ahead and dig in, man. Okay. So right here, man, it says describe the asymptote and the y-intercept of this function right here. Well, cool, man. This is an exponential function, guys, obviously, because you see you have the exponent, all right, or the exponent is a variable x. All right, this is an exponential. Now, look, what I'm going to do is I'm going to graph this first. I want you guys to see it in the calculator, and then I'm going to explain. All right, so, here's your equation, -3 raised to the x minus 5 plus 4. All right, and I'm going to graph it. And here's what your graph look like, okay? So the thing I want to point out, man, is with your exponentials, guys, you're going to have a horizontal asymptote, okay? Horizontal asymptote. HA for horizontal asymptote. All right, so we're going to say that's y. Whenever it's horizontal asymptote, it's y. All right, and in this case, this told me what it is. All right, without even looking at the graph, this vertical translation up 4 tells me where the asymptote is. All right, at y equals 4. All right, y equals 4. But as you can see, the graph doesn't pass y equals 4. All right, you can count up 4. 1, 2, 3, 4. All right. So now, man, that we know that it went up 4, that's the asymptote. This will continue infinitely in the right direction. All right, so we don't have to worry about that anymore. Okay, now it says find the y-intercept. Well, again, guys, there's a couple different ways you can do it. All right, you can look right here. There's your y-intercept. All right, you can also go to the calculator and go to second graph and go to your table. Guys, remember your y-intercept starts with 0. The x is 0, and then you have your y value. There's your y-intercept right there. Okay, there's your y-intercept right there. All right, so we have 0, 3.99 or 5. So, I'm around at the 404. All right, or 0. All right, yeah, we can go 3.9959 or 0.4. All right, just to keep it honest, man. So let me go back. The y-intercept. You can put it 0, comma, 3.99. Oops, 99. What was it, 9959? All right, or some people just write y equals 3.99. All right. Approximately 4. All right, approximately 4. Okay. So there's your y-intercept, okay? This one right here says take the function f of x. All right, we got f of x. And what we're going to do is we're going to translate this thing to the left. 3 units, so x plus 3. Then we're going to horizontally stretch it by 5. Now, remember this horizontal stretch by 5? If I want to stretch it by 5, then I got to multiply the x by its reciprocal. So 1/5. All right, 1/5 x plus 3. And then we're going to move down by 4. All right, so minus 4. All right. So this is what we're doing to the function. We're moving it left 3. All right, we're flipping it. We're going to stretch it, we're going to stretch it by 5. So I got to multiply by 1/5 directly to the x because everything in parentheses is horizontal. And then minus 4 outside because we're moving down 4. That's a vertical translation. So when I take the actual function itself, I'm going to apply these changes. All right, see the 5? All right, I know I got to have 1/5 x plus 3. Right? And then minus 4 on the outside, okay? If this was a normal equation if it was a non-exponential function, you would do that, all right? But since it's exponential, I don't need the parentheses per se because it's elevated, it's an exponent, so that doesn't apply to the exponent slide, all right? Give yourself a bell, man. Now, Moving on, man, using the parent function ln of x, write the translation of the function. So hold on, let me write it out, man. F of x, what are we going to do to f of x? All right, what we're going to do to f of x is translate 6 units right. So we go x minus 6, right? And then we're going to vertically stretch by 7. So the 7 goes out front right here. And then we got to reflect across the y-axis. Well, remember, you reflect the y-axis, that is a horizontal translation to go from over here to this side to this side. That's horizontal. So that means it goes into parentheses with the function like that. So this is our transformation to f of x. So that translates to, when you look at the function ln of x, we're going to apply this stuff in the parentheses, reflect the y-axis, all right, and then move right 6, and then we need to stretch it by 7, vertical stretch by 7. All right, because here is our function, okay? Give yourself a bell. All right. Now, for this next one here, guys, we have the height of the Cherokee rose bush in inches at age x years can be modeled by the function. Here's the function. All right, here's the function. Describe how the model is transformed from its parent. So first of all, the parent function, guys, if you look, if I strip away the stretch, if I strip away the translation, horizontal, and I strip away the vertical translation, what's left? So here's the parent function. All right, that's the parent function, okay? Now, we got to talk about all the transformations, so let me clear this off. What actually happened to ln of x? All right, so here's the parent function. We stretched it vertically by 2, so we got a vertical stretch. Oops. By 2. All right, then we have the plus 5 in the parentheses, x plus 5. Well, that means we move left 5, okay? And then we have outside the parentheses the function plus 7. So that means up 7, vertically up 7, okay? Make sure you look at your chart, guys. All the transformations are the exact same for every function, man. All right, give yourself a bell. Awesome, man. All right, hopefully you got that. Now, identify the transformations that it would take, all right, f of x to g of x. So here's f of x. All right, here's g of x. All right, so we need to figure out what transformations happen. So first of all, let's look in the parentheses. In the parentheses, I got -4 and I have +1. I'm going to sketch a little graph, and I want to show you, man, this means to the right 4. This means to the left 1. So I started off here for f of x, and I moved left, all right, to get to 1. Well, what's the distance of that? All right, how far did I move? Well, if I go 1 and subtract -4 because I want to find the distance, negative and a negative becomes positive, so 1 plus 4 is 5. All right, so it's plus 5. So since that's a positive 5, that means I went left 5. Again, you were here at 4, all right? You went left 5, and that's how you got to 1, okay? So we move left 5, all right? Now, the next thing I want to show you is, see this -2? We were at -2, and then we moved up to 5, okay? We moved up to 5. -2, up to 5. All right, I moved up. Well, how many values did I move up? What's the distance there? So if I go 5, all right, minus -2, right? That means plus. All right, I moved up 5 plus 2, which is 7. I moved 7 units up. All right. All right, if you don't believe me, count. You got -2, -1. All right, -1, 0, 1, 2, 3, 4, 5. Dude, that's 7. You moved up to 5, okay? Give yourself a bell, man, if you got that on your own. In fact, I'm going to give you one myself. Hey, Listen, man, I really hope this help y'all, man. I really do. Because I want y'all to do well, man. We're on the home stretch of the semester. Not that much to go. I want y'all to do well. Anyway, on another note, let f of x represent this function here. Find the transformation of f if g of x equals f of 1/4 x. Well, I'm just going to say this just so it hopefully it clicks home. When you have 1/4 times x, its reciprocal is 4. What that means is we actually have a horizontal stretch by 4. Our horizontal stretch by 4. But anyway, that doesn't matter. Mathematically, you see how this is 1/4 times x? We're going to do that to all these x's, 1/4 times x. So what you get is 1/4 x directly to the x. Yeah, that's in parentheses. Now we apply our degree. All right. So 1/4 x cubed plus 2 times 1/4. Oops, forgot my x. Hold on, let me go back. I'll just erase. Sorry about that, guys. Bear with me. All right, 1/4 x squared. All right, minus 7 times 1/4 x. Okay. Now, describe the transformation. Well, we described it as a horizontal stretch by 4. All right. And then basically this would be g of x. Okay. You could simplify it, guys, if you want to simplify it. All right, you would simplify it like so. You can, again, you can simplify it, okay? If you want to simplify it, you got to cube the top, which is 1. You cube the bottom, that's 64. So 164x cubed, cube, there we go. Plus, right here, square that, you got 1. And you got 16 at the bottom, so 116x squared. But then you multiply by 2. So if I were to multiply by 2, I'd really have 1/8 x squared. All right. So let me move this out of the way. I was just showing you guys what you would have. Oh, too big. There we go. You'd have 1/4 h squared. 1/8 x squared. All right. And then right here, you'd have, oops, man, my mouse pad is tripping, y'all. There we go. You'd have right here just 1/4 x, and you multiply the -7, that'll give you a negative 7/4 x. All right, that's the simplified version when you simplify. But I think you guys, I think your teachers will be okay with this one. All right. I think they just want to see you apply the 1/4 to the function, or to the polynomial. But hey guys, look, it's a horizontal stretch by 4. All right, remember anything in the parentheses is horizontal activity, whether it's a stretch, a compression, or a shrink. All right. Right here, man, x cubed plus 2, write a rule for this function. All right, g of x, f of x minus 9. So look, listen, here's f of x. All right. We're going to move f of x down 9. All right, so g of x equals f of x, all right, f of x minus 9. Y'all feel me? F of x minus 9. Okay, f of x minus 9. So now what mathematically can I simplify? All right, what expressions are like terms? These constants. All right, so I can mathematically simplify that to get g of x equals x cubed minus 7. 2 minus 9 is -7. Okay. So that's f of x minus 9 equals g of x right here, x cubed minus 7. Okay. And man, we made it to the last one. You know what I mean? Oh, by the way, I'm sorry, y'all. If you had that other one, man, give yourself a bell. Awesome, man. I love that feature. I really do. I promise you I do. Now, hey, if f of x has a y-intercept at 7, all right, has a y-intercept at 7, an x-intercept at -3 and 6, and if g of x equals f of 3x, where are the intercepts of g of f? Okay, so check this out. Let me show you. I'm going to make a quick grid. I want to show y'all something, okay? If I have a x-intercept at -3, so 1, 2, 3, and another x-intercept at 6, x-intercepts at 3 and 6, so 1, 2, 3, 4, 5, 6, we'll say right there. All right, and a y-intercept at 7, excuse me, way up here. All right, we know that this is some sort of parabola activity, okay? All right, now, but guys, that's kind of irrelevant, and I'm gonna tell you why. This right here is 3x. All right, remember how we just did the problem up here? We talked about how that number multiplied right to the x in the parentheses is a horizontal. That was a horizontal stretch. Well, this one is a horizontal shrink by 1/3. Okay, it's a horizontal shrink by 1/3. So I'm gonna put H as horizontal shrink. All right, or compression, horizontal compression. Now, I want to point out, man, that these are the only horizontal factors right here, this one and this one. All right, those are my horizontal factors. I don't really stress myself with that. All right, so what I'm going to do is find the new intercepts of g of x. I want to point out that, look, that affects the x. That doesn't affect the y. So for g of x, I can already tell you. All right, and ask yourself, this affects the x. Will this y-intercept change? All right, no, it wouldn't. It will not change. So I can tell you right now, the y-intercept for g of x is still going to be y equals 7. That won't change because, again, this affects the x value, okay? Now, because this affects the x value, all right, I'm going to show you what you can do. We know that for right here, x equals, for f of x intercept, x equals -3, okay? Well, check this out. So now, see how this is 3 times x? I'm going to apply that right here, 3x, okay? So 3x equals -3. And I'm trying to solve for the x-intercept for g of x, all right? Well, how do I solve this, guys? How do I solve this for x to find my new x? I'm going to divide by 3 on both sides. All right, so it cancels, so now I have x. And then over here on the right, I have -3 divided by 3. Well, that's -1. So this thing compressed to -1, all right, for g of x. So that's my first x-intercept. And then we're going to apply the same logic, man, to my other x value, my other x-intercept, where x equals 6, okay? Right here we have 3x. All right, so we're going to do that again, 3x. And then we're going to solve it for my second x-intercept. My second x-intercept of g of x, okay? So I'm going to divide by 3 again. That cancels. I'm left with x on the left. And right here, 6 divided by 3 is 2. So that compressed in to 2, okay? These are my new x-intercepts. All right? Which answers our question. Okay, it says, what are the intercepts of g of x? All right, we covered the y-intercept. Remember, that directly affects x. So this y-intercept at 7 never changed. Okay, it wasn't affected by that. But when you look at the x-intercepts, they got to compress in because this right here is a horizontal compression, okay? So if you already got that, man, you thought about that, you knew that, man, good job to you. You get yourself a bell, man. Oh, my bell's not working. Get yourself a bell one more time. All right, there go my bell, man. I don't know why I was tripping, man. Sorry about that. But anyway, man, hey, look, I hope this helps, okay? Yo, good luck on your test, and good luck on the rest of the semester, man, okay? I really wish you well. Have a great one.